we're just starting projectile motion. You've learned about vectors and how they have directions and so forth. A projectile is just an object that is moving both horizontally and vertically. It's an object that has been given some sort of initial velocity. It's only affected by gravity. A projectile, we can break its motion into two different categories, horizontal motion and vertical motion. The horizontal motion is side to side, and the horizontal motion is unaffected by gravity, which means whatever horizontal velocity the object has, it has it throughout its entire time in the air. Okay? It's constant velocity. And there's only one equation that we need for that, and that is velocity is equal to distance divided by time. Of course, I can rearrange that to say distance is equal to velocity times time, or time is equal to distance divided by velocity. And I'm going to put little in the velocity and the distance variables to indicate that we're talking about the x direction, not on time there. So this single equation involves all three variables that are related to the horizontal motion. And it's constant. There's no acceleration. So once an object becomes a projectile, its x velocity is unaffected by gravity. All right? In the vertical direction, however, we do have gravity. So the velocity is changing in the vertical direction. The acceleration is caused by gravity. And we have different equations to find velocity and to find displacement or distance that an object travels in the vertical direction. Last, we have time. Time is the that is common to both. Once an object becomes a projectile, it becomes a projectile at the same time horizontally and vertically, and it hits the ground at the same time horizontally and vertically. It can't hit the ground in the horizontal direction without also hitting the ground in the vertical direction, right? So time is common to both. So that means when we're missing some variables on one side, we can generally solve for them by looking time, and it crosses the two sides of equations. So the first thing to do when I'm solving a projectile problem, draw a line, make a T-chart, and I have my vertical and my horizontal equations and information separately. And then I'm going to follow essentially the guess method that we've already learned. So I look at my problem statement here, and this is number 1A. It says you're across a counter, and you accidentally slide it too hard, and it slides off the edge of the counter. The countertop is 1.05 meters above the floor. So a vertical measurement or a horizontal measurement? Vertical, right. It's in the up and down. So I'm going to put that in the vertical section. Distance dy, the y indicate that it's vertical. Normally I would have said d, right? But dy is going to be 1.05 meters. And I included a negative sign in here because it's just good habit, because we're going to look at non-horizontal projectiles, projectiles and angles, where we have positive and negative velocities and distances. So I went on and included the negative. In reality, if you count gravity as positive and height as positive, for horizontal projectiles, it works out the same anyway. Okay, what else do we know? The plate flies off at 0.74 meters per second. So is that a horizontal velocity or a vertical velocity? The plate flies off the countertop. Yeah, horizontal. So that's Vx, 0.74 meters per second. The question says, how long does it take to fall? So I need time. I need time. Can I solve for time with what I know right here? Oh, and I threw in my A, minus 10 meters per second squared. Acceleration due to gravity, you're always going to be able to use minus 10, except in the labs. The lab that we're going to do next week when you guys come back from the long weekend, we'll use 9.8. Okay, but using 10 or negative 10 is fine for approximations and worksheets and stuff. So I do have an equation. The first thing I did was I picture before I started all this, and I moved it over here. So our picture basically is showing that, right? And we've got all our measurements here. We've got our Vx, and we've got our dy. Okay. So this is the equation I'll use, 2 dy over a, and take the square root of that for time. Make sure that all of that is together before you take your square root. Depending on your calculators, I've seen a lot of you leave this out and take the square root of 2 dy and then divide the whole thing by a. You don't want to do that. When I solve for this, I end up with time is equal to 0.46 seconds. Now, what I want to see on your work is I want to see your letter equation, and I want to see your correct substitution of your values into that letter equation. And then I want to see your answer. So this stuff in between right here, I don't really care to see. These two things here. So I want to see your letter equation, your correct substitution of your values into your letter equation, and your answer. You can leave this out. I just did that for people who want to see every little step in between. In reality, I don't hardly ever do these steps because I plug this into my calculator and just go straight to there. Okay? So the second part of the equation depends, or the second part of the problem depends on us having solved this first part. Because the second part asks us, how far away does it stand? So let's look at part B. I've moved the picture over here. I know you can't do that. But we've got our time now. So we have our dy, our a, and our t, and vx. So now the question becomes, let's see if I can, here's dx is what we're looking for. I need dx. dx is equal to vx times t. Velocity times time gives us distance. And I know vx. And now, thanks to part A, I also know time. So I can solve that, put a little box around it, and I've got 0.34 meters. So again, I want to see the letter equation, the correct substitution, and the answer. Okay, let's look at problem number 2. A ball rolls off the edge of a table that is 1.15 meters high. The ball lands 0.65 meters from the base of the table. Calculate the ball's horizontal velocity as it left the tabletop. The edge of the table is 1.15 meters high. Is that horizontal or vertical? Vertical, right. So we'll plug in our 1.15 meters as dy, put in a negative sign to indicate that it's down below our starting point. We also know our acceleration due to gravity, negative 10 meters per second squared. How about the next little bit of information? The ball lands 0.65 meters from the base of the table. Is that horizontal or vertical? It lands 0.65 meters away from the base of the table, horizontal distance, and it's asking us for the horizontal velocity. So over here we're looking for Vx. Do we have an equation for Vx? We do, right? It's the only equation we need on this side of our t-chart. It's this guy. Velocity is equal to distance divided by time. It's the first equation we learned in here probably. Velocity is equal to distance divided by time. Do we have everything that we need to solve that equation? What? We don't? What are we missing? Yeah, we're missing time. So somehow we need to figure out time, the time that the ball is in the air. And we can do that from our free fall equations. The free fall equations on page 14 in your notes, or in the free fall notes that you have a few pages beyond that. And we have an equation for that. We used it in problem 1a, and that's this equation. Time is equal to the square root of 2 dy over a. So we substitute in our numbers, and we get 0.4796 seconds. Notice I left some extra sig figs in there. The reason I did that is because this is not an answer. This is an intermediate step, and I don't want to round off too much until I get to my final answer. I rounded this a little bit. I mean, otherwise it was like 9 digits long in the calculator. But if I'm going to round to a couple of digits at the end, I'll keep 1 or 2 extra in the middle so that I don't end up having too much round-off error. So now that I know the time, I can substitute that back into this equation over here on the other side, and then I'll round off, and I get 1.4 meters per second. Okay, let's look at the next one. Number 3 says, a stunt car in a movie drives horizontally off a cliff at 26.2 meters per second and lands 42.5 meters from the base of the cliff. Calculate the height of the cliff. 26.2 meters per second is the velocity that it goes off of the cliff. So is that horizontal or vertical? Horizontal, right. So we'll plug in that as our horizontal velocity, Vx. Next, we've got it lands 42.5 meters from the base of the cliff. So is that horizontal or vertical? From the base of the cliff, it lands over here. Horizontal, right, horizontal. Let's draw a picture, just in case. We have cliff. Car, well, more like a truck, I guess, huh? That's kind of what that looks like. And then, and, wait a minute. It's a movie. So what do we know about movie crashes? Yeah, fire and explosions. So we're looking for, we know this, and we know the velocity, so we're looking for this. What is the height of the cliff? So we're looking for dy. Right? So, the height of the cliff. So dy. Do we have an equation for dy? We do. Right? Yeah, there you go. 1/2 AT squared. Easy. Right? All we need is substitute in all the stuff that we know, and what happens? What are we missing? Yeah, we're missing time. So we get time. Maybe from the other side, right? We have this equation, velocity is equal to distance divided by time. And we know velocity, we know distance, so we know these two. So if we just rearrange this equation, time is equal to dx over vx, we should be able to solve for time. We do that, we have our 42.5 meters, our 26.2 meters per second. And when we do, we get 1.622 seconds. If you can read that through my fiery crash. There we go. Even better. So now I'm going to take this number, move it back over here. Now I can solve this equation. I moved it kind of to the center because I was running out of board space here. But 1/2 times minus 10 meters per second squared times 1.622 seconds squared. I'll round off at the end. Like I said, I left those extra sig figs in there. And I've also done something here. I'm going to flip the sign kind of arbitrarily, which means really for no reason whatsoever. And I'm going to say 13.2 meters because a cliff is minus 13.2 meters high, is it? We don't talk like that. We say 13.2. But really the calculation shows that it's 2 negative below my starting point because my starting point was at the top of the cliff. So your answer would be negative, but I changed it just because. We don't talk like that. We don't talk like meters in here anyway. We'd say 5 feet. Right? But we're in physics, so we'll say meters. Everybody got it? Okay. So there are 2 more problems, 4 and 5. So you got number 4, you got number 5. Oh, look. I have the answer on the board. So if I'm giving you the answers, what do you think I don't really want to see on your paper? Just answers, right. What am I really looking for? The work. Absolutely right. Okay? So when you can get this answer or these answers, then you're ready to do the worksheet. Okay? When you can get these answers, you're ready to do the worksheet. If you can't get these answers on your own,